So now that we know what the product and the sum rule is, let's take a look at the following example that applies those two rules. Let's begin by stating the problem. So if a couple decides to have 3 children total, what is the probability that A, all 3 are girls, B, all 3 children are boys, C, the first one is a boy, the second child is a girl, the third one is a boy, D, 2 of them are boys and 1 of them is a girl, and E, they produce at most 2 boys. So let's begin by creating the Punnett square. Now, the way that we're going to create the Punnett square is in the following manner. So this column basically deals with the first possibility of the child. So we have either a boy or a girl. This row basically deals with the second possibility. So child number 2 can be either a boy or girl. And this is the third possibility right over here. So let's suppose that child number 1 we're going to designate with blue. So the possibilities are we either have a boy or we have a girl. Now, what about possibility number 2, child number 2? So the same exact thing. Let's use red. We have boy or we have a girl. And possibility number 3 is also a boy or a girl. But to make this work out properly, we're going to do it in the following way. So we either have a boy or we have a girl. And we also have either a boy or we have a girl. And actually, let's change this up and do it in the same way that we did below. So we have boy and a girl. And the reason we did this is to basically work out the Punnett square correctly. So this is child number 1, the possibilities for child number 1, the possibilities for child number 2, and the possibilities for child number 3. Now, let's actually write out the fractional probability of each one of these events actually taking place. So we have a 1/2 probability of this being a boy. So let's write 1/2. We have a 1/2 probability that this takes place. So 1/2 and 1/2. We have 1/2 probability that this takes place, 1/2 probability that this takes place, and the same thing is true with each one of these events. Right? Because out of 2 possibilities, we can have either a boy or girl, and so each one of those possibilities is equally likely, and so they're given 50%. So we have a 1/2 and a 1/2, which are equivalent to 50%. So now let's actually create the Punnett square. So we combine B, red B, we have the second event, or a blue B, a red B, and a purple B. So we have a B, then we have the red B, boy, and we have the third one. And so what this basically means is this square here describes the event in which the first child is a boy, the second child is a boy, and the third child is also a boy. And because these events are basically independent of one another, we multiply their individual probability by the product rule to find the total probability of these independent events. So we have 1/2 multiplied by 1/2 multiplied by 1/2, and that gives us 1/8. Now, let's look at this block right here, this square. So this basically describes the probability. We have a boy on the first time, the boy on the second time, and a girl on the third time, on the third try. So we have a blue boy, then we have the second child, we have the red boy, and then we have a girl. And once again, to calculate what the probability of this event taking place is, we take the product of the individual probabilities of these 3 events. And so we have 1/2 multiplied by 1/2 multiplied by 1/2, and that gives us 1/8. And we continue the process. Now we move on to this square. We have a boy the first time around, then we have a girl the second time around, and the third time around we have a boy. And the probability of this is the product of the three individual probabilities, and so that is, as in these two cases, 1/8. In this case, we have a boy, we have a girl, and we have a girl. We have a boy, we have a girl, and we have a girl. And so if we multiply these out, once again, we get 1/8. And we can basically continue the process out with these four cases. We multiply them out, and we always get 1/8 in each one of these boxes. So let's continue with this one. So now we have the first time around a girl, we have a boy, and then we have a boy. So we have girl, boy, boy. So we have a girl, we have a boy, and then we have a boy again. And if we take the product, we get 1/2 multiplied by 1/2 multiplied by 1/2, and that gives us, too many markers, we have 1/8. 1/8. Okay? Here we have a girl, and a boy. So we have a boy here, we have a girl here, and we have a girl here, okay? Here we have a girl, a boy, and a girl. And here we have a girl, and a girl. And we have a girl, okay? And the probabilities are, as usual, 1/8 for each one of these. Now, notice we have 8 of these squares, and each one of the square has a probability of 1/8. And that makes sense because if we add up all these probabilities, we should get a probability of 1, which represents 100. So 100%. So what that means is one of these will actually take place. So let's move on to A. If a couple decides to have 3 children, what is the probability that A, all 3 are girls? Now, which one of these boxes describes this situation? Well, the only box that describes this situation is the final box where we have a girl the first time around, a girl the second time around, and a girl the third time around. And so the probability of that event is simply 1/8. So in part A, we simply have 1/8. Let's move on to B. All 3 are boys. Well, once again, we look at the Punnett square that we created and we look for BBB when all 3 children are boys. And this is this box here, and the probability is, once again, 1/8. Now, what about C? The first one is a boy, the second one is a girl, and the third one is also boy. Now, how many possibilities do we have like that? Well, 1 as well. We want the boy, then we want the girl, and then we want the boy. And the only time we have that is right over here. So boy, girl, boy. And so that means the probability is 1/8. Now D, 2 are boys and 1 is a girl. Now notice we are not given the order of these children, so it doesn't matter which 2 are boys and which one is a girl. All we want is a total of 2 boys and 1 girl. So the order doesn't matter. Now let's see which one of these 8 cases satisfy this situation here, 2 boys and 1 girl. So in case number 1, we have 3 boys, so that doesn't work. In case number 2 here, we have 2 boys, so the first one is a boy, the last one is a boy, and the middle one is a girl. And this satisfies this case. So the probability here is 1/8. Now let's move on to this case. We have a boy, and a girl. And once again, that satisfies D because we have 2 boys and 1 girl. And because these 2 events are mutually exclusive, meaning if one takes place, the other one cannot possibly take place. To find the total probability, we simply add up the probabilities, and this is the sum rule. Now, what about case 4? So we have case 1, case 2, case 3, and case 4. Here we have a boy and 2 girls, so that doesn't work. If we move on to case 5, we have a girl, boy, and a boy, so that works. And once again, they're mutually exclusive, so by the sum rule, we add them up. Case number 6 is girl, girl, boy. That doesn't work. Case number 7 is girl, boy, girl. Once again, that doesn't work. And case number 8 also doesn't work. So this is what we do. We sum up these 3 values and we get 3/8. So this is the probability for D. So let's box these in. And let's look at E. So they produce at most 2 boys. And this is basically the key word. So what exactly do we mean by at most 2 boys? Well, what this means is we actually have to look at 3 different cases. So at most means we can have no boys, or we can have 1 boy, or we can have 2 boys, but we cannot have 3 boys because we want at most 2 boys. So basically we have to look at 3 individual cases. When we have 0 boys, when we have 1 boy, and when we have 2 boys, okay? And then we find the probabilities of these events and we sum them up because they're mutually exclusive. So let's begin with 0 boys. So 0 boys is the same thing as saying all 3 are girls. And so we know from part A, the probability of that is 1/8. Now, the second case is 1 boy, and we don't care if this 1 boy is the first child, the second child, or the third child. So either case will actually work. So we're looking for a scenario, a case in which one of them is a boy and the other 2 are girls. So all 3 are boys. That doesn't work here. Here we have 2 boys. Does not work. Here we have 2 boys. Also does not work. Here we have 1 boy. So we have 1/8. This case has 2 boys. Doesn't work. This case does work. We have 1 boy. So plus 1/8. And here we have also 1 boy, so that also works. So we see that for this particular event, the probability is 3/8. Now, what about 2 boys? Well, this is the same thing as saying 2 are boys and 1 is a girl. And we know from part D that this is equal to also 1/8 plus 1/8 plus 1/8, or 3/8. So to find the final probability, we simply add up these individual probabilities of these 3 mutually exclusive events. So we have 1/8 plus 3/8 plus 3/8, and that gives us 7/8. So this is the probability of these 2 individuals, the couple, producing at most 2 boys. So we have 1/8 in this case for 0 boys, 3/8 for 1 boy, and 3/8 for 2 boys. And this is how you apply the product, or the product and the sum rule in genetics and probability.